Okay, Vishnu, hi.
Hello, sir.
So, yeah, Vishnu, today what we do is one more time we will take the concept of mole concept because
Okay.
it's going to be the complex one, I know, and we are doing the foundation, so we should be very clear with the mole concept. I already told you the significance of this chapter, right?
Yes, sir.
Especially the concept mole is very, very important. Not only for your foundation, whether you go to grade 10, grade 11, grade 12, everywhere this will be helpful to you.
Okay,
And
sir.
lot of the numericals which are part of inorganic chemistry can be answered with the clear understanding of this particular topic called mole. Okay.
Okay,
So
sir.
one more time, I will give you complete information along with the formulas that will help you to solve the numericals. Okay. Okay, we'll start again the mole concept from the beginning. And apart from the mole concept, what you are going to learn in today's classes, one more time, you will get clarity about how to calculate the atomic mass and what units you should use, how to calculate molecular mass and what units you should use. And if you want to calculate some bulk of atoms and molecules mass, what you should do. Okay. So these
Okay,
are
sir.
all things you're going to get one more time, complete clarity. Okay. Is that okay for you?
Yeah.
Yes. Okay. So I'm going to share my screen right now. I think you're able to see my screen, right?
Yes, sir.
So this is a topic we are going to start with. What's a mole concept? Okay. Mole and its applications. So the student who is not aware of mole may think different questions come into his mind. What is mole is all about? So here you can see some animations, what they are thinking about mole, right?
Yes, sir.
So but what is actually mole is? So here you can see in the last animation, it's a chemistry. A mole is a counting unit, right?
Yes, sir.
So how it is going to be the counting unit? Then we get a question like dozen. We say sometimes I got dozen bananas. I
Yes, sir.
got dozen apples. What does it mean, Vishnu?
Sir, dozen means like 12. So if you say like I got dozen apples means like 12 apples.
You say, okay, if I say dozen apples means you will get 12 apples, right? Yeah,
Yes, sir.
you're absolute right. It's a dozen means 12. How the word dozen is say talking about the number called 12. The same way, a mole is also a counting unit. So what is it equal to? Here you can see that mole is equal to very big number. It's not that a simple number, just like a dozen. You can look at this number in the slide. 6.02 into 10 to the power of 23 atoms. Here, these balls are which are in the weighing machine are atoms.
Okay, sir.
So how many atoms are going to be one mole? It's 6.02 into 10 to the power of 23 atoms is equal to 1 mole. If I
Yes.
ask you, get me 1 mole apples, how many apples you have to get it for me?
So one mole apples.
Hmm. How do you, yeah,
6.02 into 10 power 23 apples.
10 power 23 apples. So this is 6.02 into 10 to the power 23. Actually, it is expressed in the standard notation. But if you want to write in the expanded form, you can put almost 21 zeros beside 602. So such a big number is equal to 1 atom. Sorry, 1 mole. Got it?
Okay, sir.
Yeah. Let's see here some detailed information about this mole concept.
Okay, sir.
Look at, we are just going with this.
Okay.
So what we'll learn so far, just let me brief here for you. So what is mole here? Just look at here. So mole, we said it's a counting unit, right?
Yes.
Yeah, it's counting unit. So is it called how much? 1.60.
Sir, isn't it 6.02?
Yes, yes. I'm going with the mass. Yes, you're right.
6.02 into 10 power 20.
Yeah, it's 6.02 into 10 to the power of 23. Very good. 1 mole is equal to 6.02 into 10 to the power of 23. This much value is equal to 1 mole. 6.02 into 10 to the power of 23. So we are going to take the different things here. Let me say 1 mole apples, that is equal to what? 6.02
0 into 10
into 10
power
to the power of 23
apples.
apples. Let me take 1 mole oranges. What does it mean?
6.02 into 10 power 23 oranges.
23 oranges.
Yes.
I think you got understood what is mole. It's a counting unity equal to this number, right?
Yes, sir.
Let's now how it will help us in learning chemistry, where it will help us. So let's go to the topic called atomic mass. Look at here, this topic atomic mass. So what is the meaning of atomic mass? It is the mass of one single atom. What you have to find? Mass of
One atom.
one atom. So you might have idea about the how the atom structure will be, right? What
Yes.
is there in the atom?
So that first consists of the electrons, and then inside, in the middle, there's the
Yeah,
nucleus, which consists of protons and neutrons.
perfect. If this is the atom, at the center you have a nucleus, and this nucleus consists of protons and
Neutrons.
neutrons, and electrons are revolving around the nucleus. Is that the structure of atom, right?
Yes.
Yes, obviously. Look at here. If I am saying about the mass of one atom, so what does it mean? I need to calculate mass of all the protons present in the atom, and mass of all the neutrons present in the atom, and mass of all the electrons present in the atom, right?
Yes.
So that consists of mass of a single atom.
Yes.
Is that right? So
Yes.
it's similar to that. If you're finding the mass of a human body, it's equal to mass of all the bones, all the muscles, and all the whatever inside cells are present. It's all constitute a one human body, right?
Yes.
So here, if you add all those individually, that gives you mass of total human body, right? It's a similar to that. If you find the mass of protons and mass of neutrons and mass of electron, add them together, and it gives you atomic mass. So let me type mass of atom can be expressed as the sum of mass of protons plus mass of electrons plus mass of neutrons. Got it? So this gives you mass of one atom. So let me take the mass of, we should know what is the mass of one proton, mass of one electron, mass of one neutron. So because here they have the unique mass for one proton, one electron, and one neutron. Unique mass in the sense, for example, you take the proton from hydrogen, proton from nitrogen, proton from chlorine, proton from calcium. From wherever you take the proton in all the atoms, its mass is same.
Yes.
Okay. So because it's a proton is a unique one, it has same mass in every atom. It's the same way for electron and neutron also. So let me write here what is the mass of proton and electron and neutron. mass of proton. It's equal to 1.672 into 10 to the power of minus 24 grams. See here, you remember minus 24 I have written, not plus 24. It's minus 20 means it's minus 24 is too small. You have to put 0.000 like this, some 21 zeros you have to keep, then 670 you should write. That much small it is. Okay. So mass of neutron. That equal to, it's almost same to the mass of proton, only little bit, that is 0.003 different. Look at here. Here we have written 1.672. Here we are going to write 1.675 into 10 to the power of minus 24 grams. So that's why we'll say the mass of proton is almost equal to mass of neutron. Both are same. We'll consider both are same. The difference is you can compare. Just look at 0.03 is the difference. It's a negligible difference. So that's why we'll consider both are having same mass.
Okay, sir.
Same mass. We'll consider it as same. Next, mass of electron then. So mass of electron is 9.10 into 10 to the power of minus 28 grams.
Yes.
Look at here. If you compare with this, you have got 4 more zeros extra. After point, you got 4 more digits extra. So that's a too small comparing to them. That's why we say that electron's mass is negligible.
Okay, sir.
So how you can compare this? We can compare this. I'll give the same example again. Look at here. If you are weighing a brick on the weighing machine, okay?
Yes, sir.
You put a brick on the weighing machine and unfortunately, accidentally some cotton fell on the brick and you did not notice it. You got the weight of the printing or the print you got. It has some 2 kg of weight.
Yeah, okay, sir.
Now then you have seen that there is a cotton. So do you mind that the cotton present over the brick?
No, sir, because its mass is very
It's
less.
too small, very small cotton piece. So whether you put cotton in the weighing machine or you remove it, the brick weight, does it change? No, definitely it will not change. So it does not make any difference. That's why the cotton mass overweighing the brick mass is negligible. The same way, whenever you are measuring the weight of an atom, we don't consider calculating the mass of electrons.
Okay, sir.
Got it?
Yeah.
So we don't count them. We don't count the mass of electrons because it is negligible. Whether you add it, whether you don't add it, it does not make much difference.
Okay.
That's why we don't add it. So now, if you summary of a atom mass, that is atomic mass, atomic mass is equal to, what do you say? Mass of,
Mass of one atom.
that is, yeah, mass of one atom. What is there in the, now, what you're going to calculate? Mass of
Proton plus
protons.
neutron.
Yes, perfect. Protons plus mass of
Neutrons.
neutrons. You got this one?
Yes, sir.
Now we don't calculate what? While calculating the mass of an atom?
We don't calculate the mass of the electron
Mass of electron. Perfect. Why we don't calculate it?
because its mass is almost negligible.
Negligible. And you got the, its mass is how much?
9.110 into 10 power minus 28
Minus 28 grams.
grams. Yes.
Look at, we'll take some examples to calculate the mass.
Okay, sir.
So let me take the first one is nitrogen.
Right.
Look at nitrogen has 7 protons,
Yes.
7 neutrons, and 7 electrons. Don't
Okay.
worry how you have I got this number 777 and how you don't know about this. It's don't worry. Over a course of time, you're going to learn how to get these 7 protons, 7 neutrons, 7 electrons present in nitrogen. Okay. Now you don't worry. Just remember this. Nitrogen has 7 protons and 7 neutrons and 7
Electron.
electrons. So since we are not considering the mass of electrons, we can cancel it.
Okay.
So now the atomic mass
Is 14.
of nitrogen atom.
Yeah.
Nitrogen. It's going to be
14. 14 AMU.
okay. Yes. So how you got that one? Let me go into the detail. What information we got so far? So there are 7 protons, right? So what I do? Each proton mass is how much? 1.672 into 10 to the power of
Minus 24.
minus 24 grams, right?
Yeah. Yes, sir.
Plus, and there are 7 neutrons. So 7 into
6, 7
1.675 into 10 to the power of
minus
minus 24 grams. Again, it's same. Okay. So in these two things, well, you have to take one thing as common. That is either you can take 7 as common or this decimal value you can take common. Since decimal value is a bigger number, we'll take that one as common.
Okay.
So 7 plus 7, because I took 1.672 into 10 to the power of minus 24 grams as common thing. So how
common.
much common means here you have this one. Here also you have the same number, right?
Yeah, so but like how can we so we took 7 as common or the decimal value is common?
No, decimal value is common because I didn't write it twice. Okay,
Okay.
2 sevens I have taken common. Sorry, 2 sevens I have written already. So I
Okay.
didn't write this 2 times. So that's why I took this one as common.
Okay, sir.
Now I can write 7 plus 7 into this number.
Yes.
7 plus 7 is 14 and into what you have 1.672 into 10 to the power of minus 24 grams. Got
Yes.
it? So this is going to be the mass of one nitrogen atom. You understood?
Yes, sir.
So let's take one more atom. Then after that, we'll come back here. How you got AMU? In textbook, if you see, you will be having the atomic mass of nitrogen is 14 AMU. But
Yes.
it's not like this, 14 into this one. How you got that AMU? I will tell you later after one more example. So let me take oxygen as second example.
Okay, sir.
Look at here, oxygen has 8 protons, 8 neutrons, and 8 electrons, right?
Yes, sir.
And electrons we don't consider for calculating the mass of oxygen. So 8 protons, 8 into 1.67. So I'm not writing the 2 part because it's almost same for both of them. Plus there are 8 neutrons. So each neutron is again 1.67 into 10 to the power of minus 24 grams, right?
Yes.
Now look at here. 8 in here also, this number we have twice, even 8 also we have twice, but the larger number will take because adding these two is a complicated thing. So 8 plus 8. And you have taken this one as common, 1.67 into 10 to the power of minus 24 grams.
Yes, sir.
So how much you get? 16 into
1.67 into 10 power minus
10 to
20.
the power of minus 24 grams. Okay.
Yes, sir.
See, every time whichever atomic mass you are calculating, you have to write this number, right?
Yes, sir. Yeah.
So now what they made is, instead of writing this number every time for every atom, they made this particular value is equal to 1 unit. That unit is called AMU. So if I write AMU, what does it mean? It's
One
equal to 1.67 into 10 to the power of 24
point
grams. So what is AMU? It is called
atomic
atomic, atomic mass unit. See, what is this atomic mass unit? How do we use grams for weighing weight, for expressing the weight? How we use liters for volume? How we use centimeters and meters for measuring the distance? The same way, length and width, all those things. The same way, AMU is the measuring unit for what? Small units like atoms. Atoms are too small. Vishnu, can you hear me?
Yes, sir. Yeah.
Yeah, you're going to off. That's why I'm giving this off. That's right. Okay. So you understood what is AMU? Instead of 1.67 into 10 to the power of minus 24, every time what you are going to write now? Just
AMU.
AMU. So if someone asks you, what is AMU? What do you say?
1.67 into 10 power minus 24 grams.
Grams. Perfect. So can we write the same thing for here also? Now, what is the mass of nitrogen atom?
14 AMU.
14 AMU. Perfect.
Yes.
So you understood, right?
Yes.
How we got this 14 AMU?
Yeah.
Now, so this is for one single oxygen atom, one single nitrogen atom. So if I want to calculate it for 1 mole atoms, because in a particular reaction, you cannot take one nitrogen and one oxygen atoms and make them react together, right?
Yes.
So mass of 1 mole atoms,
Mass of
1 mole atoms, how do you find? And what do you say for this? So for example, mass of one oxygen atom,
yes, sir.
one oxygen atom,
Mass of one oxygen atom.
How much we got? 16
6
AMU, right?
AMU.
16 AMU. What is AMU? Since we are doing calculation, I'm writing its value, AMU value, 1.67 into 10 to the power of minus 24 grams,
Yes, sir.
correct? So, but I want to find mass of 1 mole oxygen atoms.
1 mole oxygen atom. Okay.
Yeah, because in a chemical reaction, you cannot take one single oxygen atom and make it react. You will take the some couple of atoms, generally that is expressed in moles. Is how much? So you know that 1 mole is equal to how much, Vishnu?
6.02 into 10 power 23.
6.02 into 10 to the power of 23. So
Yes.
this number is equal. Now you can do the simple cross multiplication. So what you get?
So then, sir, we'll get mass of 1 mole oxygen atoms in so 16 into 1.67 into 10 power minus 24 grams.
Into you have to multiply with this number, right?
Yes,
This
sir.
one, yeah, 6.02
02 into
into 10 to the power of 23. Look at here, for this 24 minus 24 plus 24, you get -1. That -1 go to the denominator and it will become 10. And you get something like this, 16 into 1.67 into 6.02.
by
So
10.
by 10.
Yes.
So on simplifying this, look at here.
Yes, sir.
So on simplifying this, you will get, so this is, you will get 16 grams.
Sir, so 16 by 10 or answer is 16?
No, it's 16 finally, after doing everything, all the calculations here. After doing all these calculations, you will get how much?
Okay, so 16.
16 grams, because here we have taken what unit? Look at here.
Yes, sir.
We have taken grams as units, right?
Yeah.
So it will go to the denominator and divide it, and you will get finally how much? 16
Okay.
grams. You can cut directly. That you can do it in the calculator, and you will get 16 grams finally. So mass of 1 mole atoms you are expressing in grams. That's why mass of 1 mole atoms, what you call it as? They has a name, gram atomic mass.
Okay, so it's nothing but like mass of one mole atom.
1 mole atoms only. Gram atomic means mass of 1 mole atom. If you're talking about single atom mass, you call it as atomic mass. If you're
Yeah.
talking about 1 mole atoms mass, then you call it as gram atomic mass. Why you are calling gram atomic mass? Because here the unit is what? Grams. That's why it's called gram atomic
Okay,
mass,
I got.
which is nothing but mass of 1 mole atoms. I'm writing here.
Okay, sir.